We're covering ACT Science Passage 4. These are the video explanations. In our DRC approach, research stands for read, R and R, right? So you're going to read, but not carefully. Just look at the process and the differences between the studies. Our R and R approach means we're going to read and then reread the question, breaking it down as we go. In the second step, the first read is just to give an idea of what is being asked. Number 22, the results of experiment 2. So put your finger on experiment 2, make sure you're looking at the correct place as the table 2, are best represented by which of the following graphs. So we have inductance. So inductance is the first column, and we see it go as it gets bigger, 10, 30, 50, 70. Make sure you draw an arrow to know which direction you're going. What is happening to the current or the amps? So it goes from 0.6 to 0.5 to 0.52. So it is getting smaller, right? So it is trending down. The only one that does that is choice H. As inductance gets bigger, current gets smaller. So H. Number 23, the circuit shown in figure 3 and used in experiment 4. So using table 4 because that's where it points us to, would most likely have had a period of 1 second. So we're going to find the period column, and 1 second means it's as it's getting smaller. It goes from 5 to 4 to 2.8 to 2. So 1 will be smaller, but had a capacitance of what? So we look at the capacitance column. That's to trend the same direction. So we know it has to be less than 2050 because the period is less than 2. That's the one that is represented here. So we look at our answer choices, and the only one less than 2050 is choice A. Number 24, in experiment 1, as soon as the switch was closed. So we have the switch right here when it's closed, right? Which of the following energy conversions most likely occurred? So it's a bit of knowledge here. There's 1 to 4 knowledge questions on every test. And you can look at the answer choices and quickly eliminate nuclear energy. It's not nuclear. It's also not gravitational potential energy, but we already eliminated it because of nuclear. So the answer has to be F. Even just process of elimination gets rid of a nuclear. So a pretty easy question in that sense, I think. Number 25, which of the following objects acted as the main voltage source in a circuit during at least one of the 4 experiments? We have to look at all of them. A little bit of knowledge here as well. So copper wire is not a source of energy. It conducts the energy, but it's not the source. Charged capacitor sounds right because it says charged, right? Resistor is not the source. In fact, it reduces the energy, right? So even if we look at said as in the experiment, it says use the inductor from experiment 1 and the charged capacitor. So that's what they're using it for, is to provide the energy. So the only one that works is choice B because we have to eliminate 1 and 3. So B. Number 26, based on the results of experiment 4, the capacitance of the capacitor used in experiment 3. So we're looking for what is the capacitance used here. Okay, so we have to figure out, well, what is the connection between the 2 tables? And the only connection we see is time, seconds and seconds. One is labeled period, one is labeled time. So it tells you in the reading, she determined from the data in table 3 that the period was 4 seconds. So the period is the time it takes to complete a rotation, right? In other words, how much time does it take to complete a circle? So if you were to break this wave apart, you start here, and when you get here, right, you break that apart to complete a circle. So that was determined to be 4 seconds. Okay, so 4 seconds means the capacitance was at 8200. You're just matching the tables. If you struggle to understand the concept, just try to figure out what in the tables matches, and that's most likely going to be where you find your answer. So the answer is H. Number 27, based on experiment 3, what is the period of this circuit? So we're looking at this circuit here, right? And so it's a little bit like the last one. How long does it take to complete a cycle? So in this one, how long would it take you to make a circle, if you will? So we start here, we have to have enough of the wave to complete a full circle. So it'd be 6 seconds. You could go back to experiment 3 where it explains what a period is. But if you know it, the knowledge, right, you just know it's from 0 to 6, so it takes 6 seconds. B. Number 28. For number 28, we're using experiments 1 and 2. It says the student is attempting to determine the inductance of a new inductor. Following the procedure in experiment 1, the student finds that after 20 seconds, the current is 0.46. So experiment 1, after 20 seconds, it's 0.46. Now we're going to go over the other table. We want to know what is the inductance most likely. So at 0.46, we see the inductance is 70 in experiment 2. So we think the inductance should definitely be greater than 50, choice J, right? All the others don't work because it's going to be a smaller amperage. Here are the question categories for this passage, so you can look and see if there's a particular category with which you struggle. Reach out if you have any questions after watching the videos. Our silly joke, since it deals with electricity, what do you call a power failure? A current event. Have a good day.